Welcome to clip 2 of 2 for 12.4 transformations. We're looking at compositions of transformations, and we're looking at doing these in the coordinate plane. Compositions of transformations, as long as they are all isometries, as long as all of the transformations are isometries, then the composition will be an isometry. And sometimes we can even describe it as a single isometry when we're done. So compositions is just combinations. We're putting a couple transformations, 2 or 3 or 4, 2 or more composition or transformations together so that they happen. So we actually have like an A double prime or maybe even A triple prime. That is because we've done multiple moves to get from our pre-image to our final image. Draw and label the results of the composition of isometries. If possible, describe the isometry as a single transformation. I've already plotted X, Y, and Z, hopefully correctly. Yep, looks like it. And we were supposed to first translate it across the vector 1, 2. Across the vector 1, 2 means that my X coordinate should be increased by 1. My Y coordinate should be increased by 2. So if you'd like to do this instead of, counting points in such a small graph, you could do this to the actual points themselves. X prime would be 3 plus 1. Y prime would be 4 plus 1. Z prime would be 3 plus 1. And then to get the Y coordinate, we'd add 2. 2 plus 2 is 4. Negative 2 plus 2 is 0. Negative 2 plus 2 is 0. Much more efficient use of time than trying to squint at the lines and figure them out. Now we do have to plot that though to show what happened. So we have 4, 4, 1, 2, 3, 4. Okay, there's X prime. It might be easy with this particular one just to move it right 1 and up 2. There's Y prime, Z prime, right 1 up 2. There's Z prime. Y prime was right here. So we've got all 3 of our points. Now we're supposed to reflect it across the y-axis. What's nice about this reflection, I could also do a rule for these. To reflect across the y-axis, I'm supposed to keep the y-coordinate as it is and change the sign on the x. So my final x-coordinate, x double prime, for this composition transformation will be negative 4, 4. My final y, my y double prime will be negative 5, 0. My final z, z double prime, will be negative 4, 0. Negative 4, 1, 2, 3, 4. Negative 5, 0. Negative 4, 0. So there's x triple prime, or sorry, double prime, y double prime, z double prime, and you can see that these are the same distance from the y-axis. So our algebra rules can save us some time, especially later if we're asked to describe them. Could I describe this in one transformation to go from here to here? Not really. This one is what we call a glide reflection. That's where we translate and then reflect. This has a specific name called a glide reflection. Other than that, though, we don't really have anything that would get us from the original pre-image to the final image, from the pre-image to the final image. All right, letter B. We're supposed to reflect over y equals 1. Because of the uniqueness of that line, I'm not going to have an algebra rule that I'm going to use. So I'm going to draw the line y equals 1. It's a horizontal line. The x would move to the x-axis because it was 1 away. It's 1 above that line, so I go 1 below to get the x prime. This puts x prime at 3, 0. The y is 1, 2, 3 points away, or 3 units away from this, so I'd continue that path 1, 2, 3 above to get my new y prime. Y prime is at 5, 4. And my z prime, it's 1, 2, 3 units away, so I go 1, 2, 3 units away to get my z prime. Z prime turns out to be right here, so that is, I'll draw this new one in green because it's a little hard to see. We're going to overlap a little bit. Z prime is at 3, 1, 2, 3, 3, 3. Nope. 1, 2, 3, 4, 3, 4. So there is our image after the first transformation. Now we're supposed to slide. We reflected it, now we're sliding it left 2 and up 3. So if I want, to every x coordinate, I can take 2 away, and to every y coordinate, I can add 3 at this point. This will give me final coordinates for x double prime. We've got 3 minus 2 at 1. Y double prime, 5 minus 2 at 3. Z double prime, 3 minus 2 at 1. All right, so we did that to get our x coordinates, and now we are looking at our y coordinate. We're adding 3 to the y's, so our y coordinate was 0 plus 3, 4 plus 3, and 4 plus 3. So we can simply plot these, because the graph is a little crazy already, instead of having to physically move every point left 2 and up 3. For z, I can just go to 1, 7 to get z double prime, which, by the way, is left 2 and up 1, 2, 3. And then for the y coordinate, I've got 3, 7. So 1, 2, 3, 1, 2, 3, 4, 6. So there's y double prime. And for x prime, it's at 1, 3. And so I get the graph, the final graph right there. Now again, down here was our image. Up here, or down here was our pre-image. Up here is our final image, because we had an image in between. And so it doesn't really look, I mean, maybe, no, it had to be, even if I tried to rotate it, it would be facing the wrong way. So this is, again, maybe a glide reflection. You could possibly come up with a way to reflect this across another line and then slide it, but it's not a single isometry. So maybe this was a glide reflection. All right, the next one says to reflect over the x-axis and then over the y-axis. This is an interesting one because I can actually do all of it without looking at the coordinate plane and then look at what happened at the end. Across the x-axis has the rule that I'm supposed to keep the x-coordinate as it is and change the y so that it changes the height. So in doing that, my in-between points would become 3, negative 2. My y prime, my image, would be 4, positive 2, because it's the opposite. I said negative, but it's the opposite of the y value. And z prime would be 3, positive 2. I could plot that one if I want to see it. Now I'm going to go to the next one, my x double prime, my y double prime, and my z double prime. And the rule for that, when it's reflected over the y-axis, is to keep the y-coordinate the same and change the sign on the x-coordinate. So going from this image, not the pre-image, because we just did a transformation, going from the image, we're now going to change the x-coordinate, the sign on the x-coordinate. So negative 3, negative 2, negative 4, positive 2, negative 3, positive 2. We keep the y-coordinate exactly as it was on the previous one. So our final image is negative 3, negative 2. There's our x prime, or x double prime. Negative 4, 2. There's our y double prime. Z double prime is negative 3, 2. There is a transformation that happened here, a single transformation. And it comes from this. When we reflect it over the x-axis, we change the sign on the y-coordinate, but not the x. When we reflect it over the y-coordinate, the y-axis, we change the x-coordinate, but not the y. So in effect, in the end, we've really changed both the sign on the x-coordinate and the y-coordinate, which if you have memorized your rules at this point, you know that this is a rotation of 180 degrees. And you can see that because if I took this image, look at where it's sitting right now, I'll keep my pen right there, and I turn my paper 180 degrees, I see the exact same image if this was the y and x axis. So that's a 180 degree rotation by reflecting over the x and y axis. Next, it's going to be a little bit different because they have y over the y-axis. So I can get my initial image by reflecting over the y-axis means I keep the y the same and change the sign on the x. So a prime would be -2, -1. B prime would be -1, 0. C prime would be -2, 3. And D prime would be -4, 0. I'm going to plot those. It saved me from having to reflect across the y-axis, although it's actually pretty easy. 2 units over, 2 units over, 4 units over, 4 units over. A is 2 units, so 2 units. So here's A prime, B prime, C prime, D prime. There's my shape, my image after doing the reflection over the y-axis. I'm also supposed to reflect across the line x equals 2. There's on the x-axis where x equals 2, that's a vertical line with an undefined slope. So now I'm going to take all of, not my black points, but my new blue points. I think I put my A too low. I did. A was supposed to be at 2, -1. That's A prime. Now I'm going to take all of those and reflect them over that line. So A prime is going to go 1, 2, 3, 4 units to get there. So on the other side, I have to go 1, 2, 3, 4. There's A double prime. That's sitting at 1, 2, 3, 4, 5, 6, -1. B double prime, or B prime goes to B double prime. It is 1, 2, 3. Oh wait, this is, no. This was B double prime. So it's 1, 2, 3 away. So 1, 2, 3 away. Right there is B double prime. Yes, that's right. And that's at 1, 2, 3, 4, 5, 0. For C double prime, let's do C double prime. 1, 2, 3, 4. 1, 2, 3, 4. Here's where C double prime is. It was above A here, so it should stay above A. That's at 6, 6, 3. And D double prime is 1, 2, 3, 4, 5, 6. Yes. Sorry, 1, 2, 3, 4, 5, 6, 7, 8. No, 6 away, so 1, 2, 3, 4, 5, 6. That will put D double prime at 8, 0. All right, letter D seems tricky. Oh, by the way, we're looking at this going, yeah, we could have had, if you look at this from the original, it's really hard to see, I know, because of all the lines and all the drawings in there. But if you look at this, here's A double prime, here's B double prime, here's D double prime, here's C double prime. Really, all of them just slid over 1, 2, 3, 4. So this could have just been a translation of right 4 units to describe it, or as a vector 4, 0. And I need to use the brackets for the vector. 4 comma 0, the translation of 4, 0, would have been from the pre-image to the final image. Save ourselves all that other grief. For letter D, they want a rotation of 270 degrees counterclockwise, unless they specify otherwise. I could simply turn my paper that many times to the left. I could also do the rule for 180, followed by the rule for 90, because 180 plus 90 is 270. So I'm going to turn my paper first just to see how it would turn out. Here's 1, that's 90, 2, that's 180, 3, that's 270. So A appears at 1, 2, A prime appears at 1, 2, B prime appears at 1, 2, 3, 4, 4, negative 1, and C prime appears at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5, negative 5. So I can actually write those down and plot those at 1, 2, 4, negative 1, and 5, negative 5. A prime, B prime, C prime. They didn't ask for any other transformations, so we're done once we connect those. There's our rotation of 270 degrees. Once again, if I were just looking at this picture, I could tell it was a rotation because let me see, they're not going to go through the same thing. Oh, for rotations, I can connect it back to A to this, A to the origin and A to that, B to the origin and B to that, and these all look like right angles that I'm creating. C to the origin and C prime to that, they all look like right angles. In fact, they are. They're 90 degrees clockwise. If I turned my paper 90 degrees clockwise, it would end up in the same place. 90 degrees clockwise is not 270 degrees counterclockwise. Identifying and describing composition of transformation, or just transformation in general. We have D to D prime. Always make sure you focus on which one's the pre-image and which one's the image. Some people would say, oh, that shifted right 1, 2, 3, 4. But that doesn't work for E to E prime because that one would then go left too. So they're going in different directions. In fact, if you were to connect them, they would each have a common midpoint. Their midpoints would all fall on a line. That line where their midpoints fall when I connect the image point to the pre-image point is my line of reflection. In this case, it's at 1, 2, 3. It's a vertical line, so it's x equals 3. It's a reflection over x equals 3. Next one's a little bit more complicated because we have 3 images all crammed into one. So I'm going to look at A to A prime first, if I can figure out where A prime is. There's A prime. There's B prime. Here's A to A prime, B to B prime, C to C prime. It looks like they're all going along a vector, the vector path that I'm following. So it looks like that would be left 2 and down 1. I'm suspecting left 2, down 1. I'm going to check it for all of them to go from A to A prime. Left 2, down 1, left 2, down 1 works. So from the pre-image to the middle image, we've done the vector left 2, down 1. Now I'm going to ignore A, B, and C and just look at A prime to A double prime, B prime to B double prime, C prime to C double prime. They seem, one went one direction, the other two went up, which is weird, so it's not a translation, and they didn't like kind of change orientation, they just seem to be above and below each other, which makes me think that it is a reflection. Just going to double check. And it is because they all have, their midpoint forms a common line, since their midpoints form a common, the midpoint of the segment connecting the image and the final image and the previous image creates this line on the x-axis. So after this, to get from A prime to A double prime, it was a reflection over the x-axis. This concludes the examples for compositions of transformations